Hi, Ben.
How you doing, Terry?
Good.
Let's go sailing.
All right. Sounds like a good plan. So this is Ben's 50-foot Farr Dunvegan here. So a really nice sailboat, like I've been saying, and we'll go aboard and do a battery test. Hi, welcome to Real World Boating. Ben McLeod here, the owner of this boat you're on now, Dunvegan. Again, I've said in last videos that it is a 50-foot Farr sloop sailboat. Actually, it's a cutter. He has two roller furlough rigs. I'll do some video footage later on, or actually put it before this, and put it in the video as we come up to it, and so you can see the whole boat and what we're talking about here. And so, as I've said in previous videos, that Ben was the owner of, he swapped over to lithium batteries there for a short period of time, and they didn't function properly for his large amperage bow thruster, and so he had to swap back to AGM batteries, is what we have aboard now. Ben, tell me about yourself a little bit, or tell everybody about yourself a little bit. I know some stuff already, because we see each other on the docks all the time. And just explain your past experience a little bit, and how long you've had the boat, and then the batteries that you had, and what happened to that system.
Okay. Yeah. Nice to be with you, Terry.
Thanks.
And beautiful day we have here on Orcas Island. I started boating as a kid, and back in the 50s, down in Florida, Coconut Grove, with small boats, and gradually working up to larger boats over time, at catamaran sloops. Mostly Biscayne Bay, Bahamas type of sailing, Keys, Florida Keys. And we had a Morgan 41 in Florida that I lived aboard for a number of years, working in aerospace down there. And then we had a move to Seattle, and we looked for a boat that would be applicable for sailing up in the Pacific Northwest. And we looked for some 10-15 years and finally found this boat, but it was in Mystic, Connecticut. And that was back in 2011, so we went to Mystic, purchased the boat, and sailed her here through the Panama Canal over about a year and a half venture to Orcas Island, where we are based now. And we've done pretty extensive cruising up here since we've been here. We've been up to Alaska, almost to Juneau. We've circumnavigated Vancouver Island, and we're in the yacht club here, so we do quite a bit of sailing here. Mostly shorter distances now, but occasionally the Alaska trip was 2 months and so forth. So we're enjoying the boat. It's a perfect boat for the Pacific Northwest because it has a pilot house, but you can actually steer from below when you're offshore using the autopilot. And we have a full wraparound bimini, which protects us when we're up in the cockpit. On the batteries, moving to the batteries, we have been looking at lithiums for quite a while now, and lithiums have some nice features. One of the most important features for me is you can take them down to a fairly low charge level without hurting the batteries, which isn't true for lead acid type batteries. And we did suffer some damage to a couple of the lead acid batteries at one point because we let them get too low during a power outage. So we made the decision to go to lithium batteries, as well as a couple of small solar panels on the boat just to hold the float when the boat is on a mooring. And the lithium batteries that we decided to go with were the Battleborn lithium batteries, and these batteries were basically replacing 2 banks of 6-volt AGM batteries, each one generating 24 volts. The boat is set up for 24 volt DC, so we pulled out basically 8 AGM batteries that were, let me see here what they were. They were 8 GGC2s, and they were rated at 180 amps per bank for a total of 360 amp hours. So those came out. We put the lithiums in that were rated at 50 amp hours each, and these were 24-volt DC batteries, 4 of them in parallel. So we put those in, let them charge, ran a bunch of things on the boat, everything was working normally. Then went out sailing about 2 weeks later and needed to use our Lumar bow thruster. Lumar bow thruster is a 200 SVTAE. It's a retractable bow thruster. They're not real common, but the rated load is 300 amps at 24 volts DC, 8 kilowatt nominal power rating, which is a little more than that 300 amps, and that is fed with through a 500 amp fuse, 24 volts DC. So we're coming into dock and needing to use the bow thruster to dock back at our dock here at Rosario on Orcas, and the bow thruster failed to operate at all. So we immediately concluded there was a problem with the bow thruster main motor because it had never been serviced since we bought the boat. So we had that motor rebuilt, and then come to find that it was actually the lithium batteries that were unable to supply sufficient power to run the bow thruster motor. Those batteries have since been sent back to the battery manufacturer for diagnosis, and 2 of the batteries were found to have failed to reset, which is not normal, so we're still troubleshooting what went wrong there. But in the meantime, we replaced those batteries and went back to AGM batteries, full river, 4 each, 6 volt DC for a bank capacity of 415 amp hours, and that runs the bow thruster with no issues. The only notes I have here: if you're going to try lithium batteries, be sure to pick something that's going to handle your peak load. Like a bow thruster would be the biggest load I could expect on a boat like this. There is reprogramming involved, including the engine alternator, your shore power charger, and possibly your solar to be compatible with the lithium profile.
Okay. Well, good. Thanks for the. See, I was in previous videos. I was actually incorrect. I think that I said that he had Victron batteries. They were not Victron 24-volt batteries.
Correct. We had a Victron controller for the solar.
Right.
Yes.
So you still have that Victron controller aboard for the solar, and so I think there was something lost in translation because he does have the Bluetooth app for the controller, the MPPT for that, similar to the one that I had the last video on with the solar panel that I ran the compressor. So similar to that app itself, basically the same app, of course different system. And so it got lost in translation that these were not Victron batteries; they were Battleborn.
They were Battleborn,
right? Okay, and they were 50 amp batteries. I know that and they were 6 volts, right?
They were 24 volts.
Oh, they were 24 volts. Correct. Okay, so they 24 volts. Now you have the 6 volts in the AGM. So they were 50 amp hour batteries. They were 24 volt, and they were Battleborns. And that was actually one of the reasons what caused me some confusion, that I was really surprised that the 24 volt Victrons did not run it. And so just lost in translation. Sorry about the misinformation there.
So it's possible that the Battleborn batteries would have worked. There's some speculation now at the manufacturer that we might have had a couple of bad batteries. They're looking at that. If you look at the specs for the Battleborn batteries, they're just not capable. It'd be marginal,
of handling that load. So I would suspect that you didn't get bad batteries from the factory. Although they should have reset their BMSs when you took them out and disconnected the power, especially after they've been sitting for a while.
Right.
And so those should have reset. So there might be a problem with their BMSs not resetting. But you had those batteries aboard the vessel.
Worked fine.
For like 6 weeks or so, right? More than a month, right?
Well, yeah, it was probably between 2 to 4 weeks.
Okay,
before we actually used the boat.
Before you actually used the bow thruster and found out it wouldn't function.
Right.
And then at first, I don't need to go into all the details of it,
Yeah.
that you didn't actually understand that you thought it was a problem with the bow thruster,
Correct.
not the batteries themselves.
Right, because I have the thruster has two motors, a up-down motor and then the
Right.
actual thruster motor, and I have had to rebuild the up-down motor in Tortola during our trip here. But the main thruster motor, they're both brush type DC motors, which require, you know, occasionally to have them rebuilt,
Yeah.
and so I did remove the main motor and had it rebuilt, thinking that it was time, you know, since we bought the boat in 2011, it had never been rebuilt.
Right, right, right. So, really nice boat. I have other people, they compliment me on my boat a little bit, but then they'll say, oh, that 50-foot Farr down there, that's amazing. So, a really nice, a very good, attractive boat. Really good lines on it. He does have a teak deck. A lot of people like that. And so, a very attractive boat. I'll show some shots, like I said earlier, about the outside of the boat to get those in there.
Yeah, thank you.
Yeah.
Teak, as far as teak decks, they're great for the Pacific Northwest, but not so great in the Caribbean, for example. They're, you know, hotter to the bare foot and more maintenance.
Oh, just because of the dark color.
Yeah, the dark color.
They get warmer.
Yeah, and then also
as opposed to just stepping on fiberglass.
Yeah.
Oh, okay.
And they get they require fairly continuous maintenance, especially in the tropics.
Ah.
So, but up here they're great, yeah, and we're completely happy with the boat. You know, we've have about 25 of them built in Sweden. And we have a group that collaborate on the internet, the owners, a lot of the owners, we share notes and ideas. Yeah.
Good, good. We're going to get the battery here shortly, the one that I built. I have a couple more things to do on that. I just looked at his connections, and so I have to add some stuff to make sure that it works properly so we can do it relatively quickly and disconnect the leads, the positive and negative terminal to his bank, and then connect it to the single battery, and you'll be able to see that. I'll show some shots of that as well, and then we'll hopefully, if all else fails. Now, we're not going to test this beforehand. This is going to be real world. If this doesn't work, I will show in the video that it doesn't work. This is real world boating, so this is the real world. I could put another, I do have the cells to do it, so it may well be in the video that this doesn't work, and we'll come back next week and finish the video and have it work. I could put another 24-volt battery in series, or sorry, in parallel to get 600 amps total, but I should be able to push 500 amps peak, actually 600 amps peak with the set, but continuous should be 400 amps, which should run this bow thruster. It's actually a 300 amp bow thruster, not 500 amp continuous duty. I was wrong about that as well. He has a 500 amp fuse that I'll show in the video as well, with his battery bank and his panel. I've already taken those videos, but I'll edit them in after this right here. And so you'll be able to see that as well. So it's a 500 amp fuse. So again, I apologize. Another thing that got lost in translation. I was thinking it was a 500 amp bow thruster itself, so it's 300 amps, which, you know, it makes more sense actually. 500 amps is a huge load. Most boats don't even have their main fuses as 500 amps. A lot of battery switches, like if you get the Blue Sea systems, which a lot of boats have for their circuit breakers and stuff, their main battery switches are not even rated sometimes to 500 amps. You can definitely get them, but a lot of them are on the 400 amp, 300 amp range, sometimes 250 amps for the main battery shutoff switches. We have, you know, the switches that you go from battery 1 to battery 2 to both, and so your charger will charge them all up, those switches itself. All right, so
there's one more comment I might make.
Yeah, go ahead.
Is the motivation. We had to switch to lithium batteries. A lot of sailors particularly will want to switch to lithium batteries because of the weight advantage. This boat weighs 37,000 pounds, so there's no issue.
Right.
You're not going to notice the difference between the AGM lead acid versus the lithium. So that wasn't our motivation. The motivation was really the charge and discharge profiles improvement, significant improvement over the AGMs going with lithium. They charge faster, and you have a much longer period of discharge, and you can't hurt them in terms of the discharge cycle.
Right.
So that's the motivation.
Well, not only that, the actual, if you look at the lithium batteries, the number of cycles that you're going to get that are actually warranted often. I'm sure that the Battleborns, I know, have a warranty. The higher end batteries do have a warranty as well, for a minimum of 2,000 cycles. And for the lithium iron phosphate batteries, which a lot of people are going to, the ones that I have are lithium ion batteries, but they're not lithium iron phosphate. The ones that we'll be testing today, those ones, they're 3,000 to 5,000 cycles often. So you're talking a really long time. And then, you know, if you want to get to exotic type stuff, like the lithium titanate batteries, they're talking 20,000 cycles. You're talking, you know, longer than I will be alive. Those batteries will still be good. So a really long time for those lithium technologies. So it's not only what you said, the fact that you can run them down, and but they will last for so much longer. The initial expense is more expensive by oftentimes 4 times.
Right.
But the actual longevity should be on the order of 8 to 10 times more. So in the long run, you're supposed to. And a lot of this newer technology hasn't been around long enough to say, yeah, they last for 20 years, because they haven't existed for 20 years.
Right.
So we'll see. Time will tell. So we'll move on to having me finishing up getting the battery ready, and then we'll show the actual, hopefully, bow thruster working.
Fingers crossed.
Yeah, thanks.
Thank you, Terry.
All right, this is the battery well for Dunvegan on Ben McLeod's 50-foot Farr. And this is his existing batteries here, so let's see if I can't get some shots of the whole battery well there. There's these are AGM batteries, 24 volt, right? Are they?
They're 6 volt.
They're 6 volt batteries, sorry. 6 volt batteries, but the 4 of them make the 24 volt system that he has. So just wanted to get a shot of the existing before we took off some terminals. Now we're not going to pull these out. We're going to leave them in. And so on top of these you'll see the battery that I built. And then we'll connect up the positive and the negative terminals there to those, and we'll go from there. All right. On these lithium ion batteries, here is that label that I talked about in the last video. I'd had a couple people ask about a close-up of that label itself. So I just wanted to get a good shot of that so people could read it. And again, these were the batteries from a couple of videos ago that I talked about during the battery selection. And I had some questions about the actual label from that. And these are the ones, of course this is not sponsored, from batteryhookup.com. So I just wanted to get that label out there. So there's that. So I'm going to make a jig so I can make some terminals, some bus bars essentially, to connect the different cells together to each other. So this is the jig that I'm creating for that. I just want to be able to drill real precise holes, so I'm going to create a jig and go ahead and use a drill press and drill the holes through some copper that I cut up into pieces to create bus bars. So all I did was just draw the end tabs, and that's what the end tabs look like on the cells that I'm going to be using for the 24 volt battery. And again, the whole point of this is so I can create a battery to run that 24 volt, 500 amp 24 volt bow thruster on Ben's boat, Dunvegan. And so here's the jig that I started. So I'll show drilling it out and my jig after I carve out a place to put the copper inserts and get a shot of that as well. So I just wanted to show the jig that I built. Here's the piece that I cut out. I just used some chisels here and cut out a space. And here is the jig that I made. So my copper pieces, which there's a bunch of them cut right there, will fit right into the slot. And then I just throw a piece of tape over the top of it. Actually, I cover the whole thing with tape to hold it in there and in place, and then go ahead and go to the drill press and drill it out. So I actually start from this side and drill through the copper plates so my alignment is proper with the holes. So just a simple little jig, easy peasy, no big deal. And then I'll show the actual drilling process here in just a moment. Alright, I have my jig here again, and there's the piece of copper underneath the tape right there. And so I'm just going to drill a couple holes real quick using the jig. So what I like to do is put the drill in the hole already, so I don't, when I'm doing a bunch, I don't round out the hole too much. And then go ahead and just hold the jig, flip it on, and then go ahead and just go through nice and slow. Don't try to use the drill fish too hard. This copper is really soft, so it really doesn't take that much to go through that. So I'll flop that up, go ahead and turn it off. Look at the hole, looks good. And then again, just repeat the process for the second hole. Put it in the hole, turn it on, go ahead and push it through. Nice and slow. Peel that piece out. And then peel that masking tape off. That I'm just using simple masking tape. There we go. It's we got a bus bar that's drilled out for those cells. They're specifically custom made for that. So there's that. And there's the jig. So again, pretty easy. All right. Get another one. Okay, well, we have the lithium-ion batteries installed aboard Ben's boat now. So here's that. Let me zoom in on that. You can see the negative battery connection, and the positive battery connection is actually on the side. Now these cells are 3.6 nominal voltage. They're 8 amp hours. So in order to get the proper voltage for the 24 volt battery, his system here, I did 2 7 cell in series, so 7S and 2P. So 7S, 2P means parallel. So instead of 8 amp hours, I now have 16 amp hours. Approximately 26.7 volts, 26.69 right now. We're gonna kick on the charger here and turn on the battery switch and get things going, and just do some simple testing to make sure everything is hooked up right. We don't want to ruin anything on Ben's really nice boat here. And so we're gonna do that right now. So there's that. Alright, here we are in Dunvegan's aft berth, and this is where his electrical distribution panel is. This is where the power comes in from the battery, and you can see all of his fuses. Again, this is a 50-foot Farr Dunvegan, so this is pretty interesting. A lot of boat distribution do not have fuses like this. They'll have circuit breakers. But he does have a few circuit breakers as well, so it's a lot of them are double protected. And in here, right here, is you can read the note potentially on the blue tape. It says bow thruster fuse, which is right there. And I don't know if you can read it. There is your 500 amp fuse there. And so that's what we're going to be running with this battery that I built here. And so pretty interesting. His main fuse is here. For the whole boat, it is an 800 amp fuse. So I have not actually seen a fuse that large before in a vessel, but I'm sure they exist. All right. The second I'm filming now. All right, here's his battery select switch, his system control, and you can see the 26.7 is fluctuating around a little bit. Hey Ben, go ahead and turn on that battery switch.
Okay, one thing that is going to happen is I think the fresh water pump may run.
Okay.
Okay, there we go.
That's fine.
Okay, I must have turned the pump off.
Yeah, we didn't hear anything, and the voltage did not change. Okay. So it looks like there's probably no loads, or at least no significant loads at all.
Do you want me to put a load on it?
Yeah, let's do just some small load right now.
How about the fresh water pump? Ready?
Yeah, go ahead.
Looks like it's running.
And it did, oh actually, I should have kept it on the meter. It did drop down to 26.2 volts while that was pumping. So why don't you go ahead and turn on your, go ahead and plug in your shore power if you would. Okay. You can close that, or is your shore power plugged in? You just have it switch off?
Have to turn the switch off.
Oh, okay. So Ben's going down to turn the shore power on. And so we're going to charge that for a little bit as well.
Okay.
All right, it jumped up really quickly to 27.5, 27.52. What do you have for your
Float is I think 27.5.
the float?
Bulk is probably 28.5.
Okay.
Like that.
Okay. So let's go ahead and let this charge up a little bit, and then we'll bring down the bow thruster and see if we can actually make this happen.
Okay.
All right. All right, we're going to do a bow thruster test now. So this Ben's going to work the controls and do the bow thruster. So first he's going to go down. Go ahead, Ben. Go ahead.
Right, we're going to deploy the bow thruster down, and this is, of course, the left-right. You can kind of hear a little groan in the front of the boat.
That sounds like it's deploying down at least.
Yeah. When it gets all the way down, the down light will come on. There we go. Okay, we're ready for action.
All right, so now we're going to test that battery. The one that I built, the one that you should have saw earlier.
Right.
I'll edit it in, and here we go. We're going to see real world test. Not tested before. We didn't do this beforehand, so if it fails, it fails. If it doesn't, it doesn't. Here we go.
We're going to go bow to port. Pretty good. Bow to starboard. Looks like it works.
Nice.
Do you want to see what the current is on the meter when I do that inside?
Yeah, that should be recording it, right?
It should be, you're right, yes. Okay.
So we should have a second camera on his meter there.
Yeah, that was,
we'll check it here in a little bit to make sure the camera stayed.
That was quite
and
effective.
Didn't slide or move or anything.
Okay.
Why don't you go ahead and give it some actual time.
All right.
Make it like you would if you're actually docking. So you're going to be holding on it to like...
Not long.
Like maybe 10 seconds though.
Yeah.
So go ahead and count 10 Mississippi in your head, or
5.
You can do it out loud if you want.
1, 2, 3, 4, 5. That's normal, about.
Okay.
Okay. And now we're going to go the other way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Awesome.
Very impressive.
Yeah, it works. So you can build a lithium-ion battery yourself for relatively inexpensive. That will run a 300 amp bow thruster on a sailboat. So that's good test satisfactory. I'm glad it actually worked. I was a little bit nervous about that.
Congratulations, Terry.
Thank you. Thank you.
Yeah.
All right, we'll go check the the meter itself here.
Okay, we'll do that. Very good.
Good.
I'll stay here, and when you say do it again, we'll do it again.
All right, we'll go to the other camera here.
Okay.
Okay, go ahead, Ben.
Okay.
So that's really weird. It only topped out at 170 amps or so. Go ahead and do it.
Maybe because the charger is on, right?
Could be.
Because it would be the sum of the current.
So right now, just sitting here with nothing,
Yeah.
it's like 16 amps. It's dropping.
Yeah. Okay.
Now we're down to 15 amps,
Okay.
14.7 amps.
Right. Because it'll do, you know, it'll do 100 amps.
This meter, you mean?
No, well, the charger will.
Oh, okay.
Yeah, it's capable of it.
How many 100 amps?
100 amps.
Oh, okay. We'll see. Why don't you do it again,
Okay.
and then we'll see if it pops up. I think that the, you know, like on a car starter and stuff,
Right.
they have the initial amperage.
Right.
I don't think this meter is fast enough
Okay.
to detect that.
Right. I don't.
So you're not getting the initial like 300 amps or 350 amps or whatever.
That's right. Yep.
So go ahead and do that again.
Here we go.
It topped out 191 amps.
Okay. So steady state is probably why they're. Well, I don't know. So maybe 300. Maybe that.
Bow thruster test here to push and port, so you can see the wash and the boat move there. I'm going to walk back behind Dunvegan here, and you can see the stern and the name. And now we're going to do the starboard side thruster. Go ahead, Ben. You can see that wash up there as well. So both sides work well. And I'm going to go up and get a close-up shot of the starboard wash here, since there's a dock right here. Go ahead, Ben. All right, excellent. So that basically concludes our video on installing a 24-volt battery into a sailboat here. So it was a pretty good test. I'm really happy with it. Hi, Terry again here. I just wanted to go over some stuff with the battery that we just got done doing the video for Ben's boat. It's kind of an accordion almost, the way I have set it up here. So, I did make some bigger tabs here, as you can see on this, for the main battery negative, and then as well as the main battery positive. I have that. I used these terminals for electrical standoffs that I purchased, really inexpensive, and just make sure that nothing can touch each other. And I used the Kapton tape, the high temperature electrical tape, quite a bit. And as you can see, I have the battery hookup tape. So I did order these from batteryhookup.com, and so they comes with tape on the terminals, or on the ends of the battery, both the positive and negative side. They keep them isolated, so good packaging from them as well. And so, and then if you can see how I did this, especially on the that positive cell here. On the rest of them, I just have the two smaller plates on all these, with the 1/4 inch. I actually used 6 millimeters, so M6 connections for that, and I did 2 on each one, and plus a large 3/8 connection for the actual battery connection to the boat when we hooked it up to Ben's boat there. So I wanted some particulars of these, and as you can see, this side is the positive side and this side is the negative side. So I have 7 in series, and this is actually the midpoint, that's why, and then 7 in series here, 3.6 nominal. As you saw on the voltage meter, we were getting like 26.7, 26.68 when we first hooked it up, and it was a satisfactory test. It did run his bow thruster for a good long time. He did about 15 seconds each port and starboard, and we did it several times, so normally that's his usage. Every once in a while in a wind situation you would be running that, but again, this is only like 25 pounds here, and that includes all this copper plates and everything, which adds a substantial weight to this. So so pretty light, but again, this is only now 16 amp hours, 8 amp, 7 of them for 8, and then the other 7 for the other 8 for the 24 volt batteries. So 7S2P would be what I was using. And notice I didn't have a BMS connected to this. You would want to get a BMS like a 7S and connect that to the positives. I don't have a 24 volt system, and I have a 12 volt system, and so I'll be using probably 4S system, 12 volt, and then have a bunch of them in parallel. I will make a battery for my boat with these. I do have quite a few more because I was going to make a substantial battery with this, and that will be my starting battery that I was going to have aboard my sailboat because of the high amperage ability of these, and so I did want that high amp load for my sailboat itself. So yeah, everything, I'm really happy with this video, and I'm glad that it worked without being tested first. I was a little bit concerned about that. So just want to get me in the shot a little better here. So I hope you enjoyed the video, and at least this series. This was a while in coming, and I know that my whole impetus of creating a YouTube channel and starting these videos was Ben and his lithium problems there, and I really learned a lot in doing these videos. I'm going to move on to other subjects. I may do a couple more solar videos and some other things in the past, but my emphasis will not be on, in particular, on batteries and charging systems and things like that. It's going to be more of a boating website. This just happens to be where I started, and Ben and his problems with that was the reason why I started this in the first place. So hopefully you enjoyed the video. Thanks for watching, and please subscribe like everybody else says on YouTube. And I'll continue to make videos. And if you have any things you particularly want to see within reason, I can't do everything, of course. Nobody can. And with boats in particular, and I am more of a sailboat guy. I do have a small powerboat and another small sailboat as well. It's a Glassline 22 sailboat that I use for day sailing. My Spencer 5153, which is right here, laissez-faire. And I do have a small powerboat, like an 18-foot powerboat that I use for crabbing and things like that. So I do have some powerboat stuff that I can do. I don't do a lot with that. I'm more working on laissez-faire, getting it ready for cruising. So thanks again for watching, and have a good day.